NASA does a lot of cool research. They don't just study how the universe works. They're interested in developing all kinds of cool tech that will help them reach their goals. And they've got research grants up for grabs to people with great ideas. One such grant program is NIAC, which looks for innovative advances within the field of aerospace. That's a pretty wide net, covering everything from novel propulsion methods to astronaut loungewear, which means that there are some pretty interesting grant winners. NIAC gives out its grants in 3 phases. Phase 1 projects get $125,000 for 9 months. That gives the recipients the time and cash they need to get their ideas off the ground. Phase 2 projects get $500,000 for 2 years to continue working on Phase 1 successes. But this is the first year NIAC has awarded Phase 3 prizes, a cool $2 million to spend another 2 years getting the technology ready for actual implementation, whether by the government or by private industry. And the first 2 winners were just announced last week. The first Phase 3 project is called Mini-B, and it does not actually involve bees of any size. It's part of an effort to mine asteroids using sunlight. TransAstra, the company behind Mini-B, plans to eventually capture asteroids in giant bags and mine them for resources like water. Mini-B itself is a prototype which will operate in low Earth orbit, but TransAstra eventually plans to move beyond Earth with bigger, better spacecraft. Their trademarked technique is called optical mining. It focuses sunlight onto a single point on the asteroid's surface, a bit like burning an anthill with a magnifying glass. And that creates a giant light drill that vaporizes water and other compounds from the asteroid. As they fly off the asteroid, the spacecraft would collect them inside a giant space bag. Mini-B won't have that capability. It's more of a step toward that eventual goal. The company hopes that by the end of Phase 3, they will see the Mini-B ready to apply for different higher-level NASA funding programs. The second of these projects, called Skylight, is run by Astrobotic Technology in partnership with Carnegie Mellon University. They're developing imaging technology to create 3D models of craters, but not just because, that looks super cool. Instead, this project seeks to determine if a given crater is a feasible destination for a robotic or crewed mission on the Moon, Mars, or potentially other rocky bodies. The goal is to use a group of autonomous micro-rovers to create 3D models on site and on much faster timescales than what we can do with current technology. The models would tell us things like how navigable the rims are and whether there are any caves, whether there's a good route for rappelling. Yes, like rock climbing. Apparently that's a viable way to explore Mars, potentially. As an added bonus, the tech could be used here on Earth as well to monitor artificial pits, like quarries. If these 2 missions don't sound exciting enough for you, NIAC plans to award 1 Phase 3 project every year, so keep your eyes peeled. Maybe one day NIAC will award Phase 3 funding to a mission to hunt for extraterrestrial life, but until then, astrobiological research is left to other capable folks. And last week, a paper published in the Astrophysical Journal suggested a lot of planets out there might have atmospheres that are toxic to complex life as we know it. One of the big problems with the search for alien life is that we only know of what conditions Earth's life can survive in. And that's a wider range than you might realize, like there are microbes that can live inside of nuclear reactors. But when it comes to identifying planets that could be home to alien life, we have to start somewhere. Usually we look at planets located in their parent star's habitable zone. That's the orbital distance where an Earth-like planet would need to be for the water on its surface to be liquid. Not too hot, not too cold, just right. That might be enough to support alien microbes, but most complex life as we know it needs more than just liquid water. Among other things, it needs a favorable balance of gases, including toxic ones like CO2 and carbon monoxide. So a team of astronomers ran a set of computer simulations taking into account how animal life on Earth can tolerate those toxic compounds, primarily animals complex enough to use blood to transport oxygen. And we already knew that some amount of atmospheric carbon dioxide is necessary for planets that are further away from their star to act as a greenhouse gas and keep things warm enough to maintain liquid water. But according to this team's simulations, at the outermost region of the habitable zone, the amount of CO2 you'd need is over 10,000 times more than what Earth has in its atmosphere, which would be toxic to animal life. Once you account for how much CO2 would be in the atmosphere, the habitable zone starts to shrink. like by half for simple animal life, and 2/3 for human-like life. Some stars, like cool red dwarfs, throw another wrench into this system. A planet with organic life and an oxygen-rich atmosphere like Earth slowly builds up carbon monoxide, which is toxic to animals that use hemoglobin to transport oxygen in their blood. It starts to bind to the iron that would normally carry oxygen and just generally makes things a mess and you die. But certain wavelengths of ultraviolet radiation from our sun keep carbon monoxide levels in check. Red dwarfs, however, don't produce enough of that radiation. So for mammals like us, no planet in the habitable zone of one of those cool, dim stars would be safe. Of course, the number of planets that we know for sure can support complex life is 1. Until we find complex life in a place we'd classify as uninhabitable, we won't know what kinds of terrifying scenarios alien critters might be able to call home. Like, we won't know if life can evolve to tolerate tons of carbon monoxide until we see it. But further work, including actual observations of exoplanet atmospheres that go beyond computer simulations, will help us identify where our time might be best spent hunting. Thanks for watching this episode of SciShow Space News. If you enjoy SciShow, you will definitely enjoy our podcast, SciShow Tangents. It's got me and Stefan Chen from over on our main channel, as well as SciShow producer Sam Schultz and Crash Course's Sari Riley. Once a week, this group of fascinating humans gets together to share the most fascinating, mind-blowing science facts we can get our hands on, sometimes with like a slight competitive bent. There's even science poems, if you want some of those. I do. Tangents is a collaboration between Complexly and WNYC Studios, and it comes out every Tuesday. If you want to hang out with the 4 of us every week, find it wherever you get your podcasts. It's so fun. Check it out. Just give us one try. Give it a try.